You hear it all the time, like researchers, oh, they can just tweak their methods to get the results they want. But is that actually true when we're talking about meta-analysis?
That's a great question, and it's something that Guinness and his colleagues really dug into in their research.
Yeah. Today we're going to dive into their paper. It's
Yeah.
a fascinating one. They didn't just, talk about this idea. They actually analyzed 196 published meta-analyses
Yeah.
to see what researchers are actually doing out there in the wild.
196 meta-analyses covering over 5,500 individual effect sizes. It's a lot of data.
Yeah, it's pretty impressive.
Yeah.
Now, before we get too deep into the weeds, could you give us a quick refresher on what a meta-analysis actually is for those of us who aren't, stats whizzes?
Absolutely. So imagine you have a ton of research on a single topic. Let's say, I don't know, the effect of video games on aggression.
Okay.
A
Yeah.
meta-analysis is like taking all those studies, pulling out the key findings, and then using statistical methods to combine them and find the overall effect.
So it's like a super study,
Mm.
a study of studies.
Exactly. And it's become a really important tool, especially in the last few decades.
Have they? Why is that?
Well, Guinness and his colleagues found that there's been a huge increase in the number of published meta-analyses since, like, the year 2000.
Oh, wow. So this deep dive is definitely timely.
They even predicted that by 2020, we'd be seeing over 1,200 new meta-analyses published every year.
Wow, that's a lot of meta-analyses. So one of the big questions we're going to explore today is whether all those choices researchers make when they're doing a meta-analysis, like which studies to include or how to handle missing data, do those choices actually impact their conclusions?
Right, because there's always this debate about whether those methodological tweaks and judgment calls really make a difference in the end.
And what did Guinness and his team find? Did those choices have a big impact?
Actually, what they found is that those traces had surprisingly little impact on the overall effect sizes.
Really? That's kind of shocking. I would thought things like, I don't know, excluding certain studies would really skew the results.
It seems intuitive, right? But when they looked at it, the average effect size remained basically the same, regardless of whether researchers made certain choices.
So even when researchers make different decisions about which studies to include, the overall findings are pretty consistent.
Exactly. And it was the same with things like reporting a fail-safe statistic or not.
Hmm. Now, I know fail-safe statistics sounds super technical, but can you break that down for us non-statisticians?
Of course. Think of it this way. Sometimes studies with negative or less exciting findings don't get published. It's called publication bias. A fail-safe statistic is basically a way to check whether that bias might be skewing the results of the meta-analysis.
Uh-huh. So it's a way to make sure we're not getting a biased picture of the research.
Exactly. But even when researchers did include this check, it didn't really change the average effect size they found.
Okay, so that's pretty reassuring. It seems like meta-analysis is more robust than some people might think. But what about statistical corrections? Things like adjusting for measurement errors. Did those have a bigger impact?
That's a good question. And it is true that they found those corrections did lead to statistically larger effect sizes.
Ah, so there's a catch.
Well, you could say that while the effect sizes were technically larger, the actual increase in explained variance was often tiny, like really tiny.
Okay, now I need a little help here.
What?
What exactly do we mean by variance explained? And why should I care about that?
Great question. It basically tells you how much a theory actually helps us understand or predict something.
Okay.
So let's say a theory explains, I don't know, 10% of the variance in job performance. That means it only gives us a small piece of the puzzle.
So the statistical corrections might make the numbers look bigger, but they're not really adding much to our understanding of the phenomenon.
Exactly. They found an average increase in explained variance of just 0.25%.
Wow, that's pretty small.
Yeah, and this pattern held true across all sorts of different topics. They looked at leadership, job satisfaction, you name it.
So if all these methodological choices aren't really making a huge difference, what does make a meta-analysis stand out? What makes it influential?
Now that's what we'll dig into next.
Okay, so we've learned that all those methodological tweaks and choices researchers make, they don't actually have a huge impact on the findings of a meta-analysis.
Right, the impact is much smaller than you might expect. But that begs the question, what does make a meta-analysis influential? What makes some stand out from the crowd?
Yeah, what makes certain findings really catch the attention of other researchers?
Well, one of the things that Guinness and his colleagues looked at was whether the focus of the meta-analysis mattered. So, was it focused on testing existing theories, or was it trying to build new theories?
Ah, interesting. So are you saying that a meta-analysis that's putting those well-established theories to the test, that might be more impactful?
That's exactly what they found. Those theory testing meta-analyses, they tended to get cited more often by other researchers.
Okay, so it's not necessarily about coming up with some groundbreaking new theory. It's about taking those ideas that are already out there and really putting them through the ringer?
Yeah, I think that makes sense if you think about it, right? Scientists are always building on each other's work. So when a meta-analysis comes along and confirms or refines an existing theory, it's going to get a lot of attention.
It's like adding another brick to that wall of knowledge,
Mm.
helping us build a more solid understanding.
Precisely. But then there's the flip side. What about those meta-analyses that are trying to build new theories? What did they find about those?
Yeah, because those seem like they'd be the real game changers, right? The ones that could potentially revolutionize our understanding of a topic.
You would think so. And what's interesting is that those theory-building meta-analyses, they actually tended to find larger effect sizes.
Wait a minute, hold on. So the meta-analyses that are venturing into new territory, they're finding bigger, more dramatic effects, but they're not getting cited as much.
It is a bit of a head-scratcher, isn't it? It seems counterintuitive.
Yeah. I mean, wouldn't you think that those big, attention-grabbing findings would be the ones that everyone wants to talk about?
You'd think so. But the study's authors have a possible explanation for this paradox. They propose that theory building is inherently more exploratory.
Ah, so there's more room for those big, splashy findings, but maybe they're not always as rock solid.
Exactly. It's like those early explorers sailing into uncharted waters. They might come back with tales of amazing new lands and riches, but those discoveries still need to be mapped and verified.
It's that initial excitement, but it needs to be tempered with a healthy dose of skepticism.
Right. And that's where theory testing comes in, providing that rigorous examination and verification.
So those theory testing meta-analyses, they're like the cartographers, carefully mapping out those new territories, making sure we have an accurate understanding.
That's a great way to think about it. And it's important to remember that those initial groundbreaking findings don't always hold up under further scrutiny.
Yeah, sometimes those shiny new discoveries turn out to be fool's gold.
That's right. Whereas theory testing, it's all about confirmation. It's about taking those well-established ideas and seeing if they hold water in different contexts and with different samples.
So the effect sizes might be smaller, but the findings are more likely to be, what, reliable in the long run.
Exactly. It's about building that solid foundation of knowledge.
This is all really fascinating. But there's one finding in the study that I have to admit, it really surprised me. I always thought that meta-analyses with those big, impressive effect sizes, the ones that seem to explain a lot about a phenomenon, those would be the ones that automatically get more attention.
Yeah, it seems logical, doesn't it? Big effect, big impact, lots of citations.
Yeah, exactly. But the study found that that's not always the case.
That's right. It seems that what researchers find interesting doesn't always align with what's most important in terms of a theory's predictive power. It's a bit of a disconnect.
So if big effect sizes don't guarantee citations, what does? What are those key ingredients that make a meta-analysis truly influential?
That's a great question, and that's exactly what we'll explore in our final segment.
All right, so we've been talking about this kind of weird thing with meta-analysis, right?
Yeah,
It seems that bigger isn't always better.
exactly. Having those impressive, huge effect sizes doesn't automatically translate into more citations.
So what does make a meta-analysis really stand out? What makes it influential?
Well, Guinness and his colleagues, they didn't have a simple answer.
Okay.
But they did point to a few factors that seem to be linked to getting more attention from other researchers.
Uh-huh. Like what?
Like, for example, using that Hunter-Schmidt approach, focusing on theory testing, and even, get this, reporting correlation coefficients, like those R values, instead of Cohen's D.
Wait, really? Just using a different statistic makes that much of a difference?
Well, it seems that researchers are often drawn to meta-analyses that align with what they're used to, what's familiar to them. It's like speaking the same language.
So fitting in with the existing norms of the field, that's important.
Yeah, you could say that. Take the Hunter-Schmidt method, for instance. It's super common in management research. So when researchers come across a meta-analysis using that approach, it just feels familiar,
Right, like it fits in with their expectations.
Yes, exactly. And this whole idea of familiarity, it plays out with theory testing as well. Think about it. Researchers are often working within established theoretical frameworks. So a meta-analysis that kind of backs up or refines those frameworks, that's going to resonate more strongly than something that's completely out of left field.
It's like building on that solid foundation of knowledge.
That's it.
Yeah.
And then you've got the R values versus Cohen's D. In a lot of fields, particularly in management and applied psychology, those correlation coefficients, the R values, that's just how researchers think about relationships between variables.
Yeah.
So using those familiar metrics, it just makes the findings easier to grasp.
So it's all about presenting those findings in a way that's comfortable and easily digestible. But doesn't that preference for familiarity create a potential problem?
How so?
Well, I mean, if we're always sticking to the tried and true, aren't we potentially missing out on new ideas, on innovation?
That's a good point, and it's something we should definitely be mindful of. While familiarity might play a role in grabbing attention, it's not the only thing that matters. There's also the importance of the topic itself.
Right, of course, the substance of the research.
Exactly, and the rigor of the analysis, are the methods solid?
Right.
And then how are those arguments presented? Are they clear? Are they persuasive?
So it's not just about fitting in. It's also about making a strong case for the significance of those findings.
Precisely.
So for all of us out there trying to make sense of the research landscape, what's the key takeaway here?
I'd say don't get too hung up on the nitty-gritty details of every single methodological choice.
Okay.
Instead, zoom out and focus on the big picture. The strength of the theory, the quality of the studies included, and the clarity of the conclusions.
So look beyond those statistical details and really grapple with the heart of the matter.
Absolutely. And don't be afraid to explore those meta-analyses that challenge conventional thinking or introduce fresh perspectives. Those could be the real hidden gems that lead to some truly groundbreaking discoveries.
That's a great point. Sometimes the most influential ideas are the ones that maybe didn't get a lot of attention at first. So as we wrap up this deep dive into the fascinating world of meta-analysis, we want to leave you with one final thought to ponder. If familiarity isn't the only driver of attention, what else is going on? Is it the urgency of the topic, the elegance of the methods, the reputation of the researchers involved, or something else entirely? We encourage you to continue exploring and let us know what you discover. Thanks for joining us for this deep dive.